Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java. Today's data structure is queues. Let's get started. In the earlier video we covered stack, and in this one we'll be covering queues. So stacks and queues are very common data structures that are used, but let's understand queues today. So firstly, a queue is a linear data structure that follows first in first out principle. So unlike stack, which used to follow last in first out, queues follow first in first out. So it's like when you stand in queue for a movie ticket, whosoever came first will get the ticket first. So that's an example of FIFO or queue. Generally it has two key operations: enqueue, adding an element to the end of the queue, and dequeue, removing an element from the front of the queue, because the elements get added from one end and then they get removed from the other end. Let's understand this. Okay, so firstly, if you remember from stacks, it is something like this, right? When you enter an element 1, then 2, 3, 4. Suppose the list was 1, 2, 3, 4. 1 came first, it entered first. But now when you want to remove the elements, it will remove the last one first. So it will be 4, 3, 2, 1. So first come and last out. So this is, and last come, first out. So this is LIFO, last in first out. Now unlike this, queue is something like this. You have a queue data structure. You have to imagine it. Okay, and again you have the same numbers 1, 2, 3, 4. So let me remove this one. Okay, so you'll enter 1, then you'll enter one more, so not one here, let me do it without this. Okay, so this is what a queue would look like. Okay, so when you get 1, you insert 1 in the queue. Okay, so 1 is inserted, 1. This is the front part, front. This is the end. Okay, so you insert from one side and remove from the other side. So you inserted 1, 1 is here, then you insert 2. So 2 will get inserted on the front side, 2. So 1 was earlier here, now 1 gets removed from here, and 2 comes here, 1 comes here. Then you get 3, 3, then you get 4, 4. So this keeps shifting. So it becomes 1 was entered first, 1 was entered first, then 2, then 3, then 4. Okay, since 1 is entered, so there is actually no shifting happening. Rather, if let's say you are using linked lists for the implementation, it could be like this, that 1 was there, now you want to insert another number as 2, you create another node 2, you link it to 1, you make this as the front and this as the end. And when you want to remove the elements, you'll remove from this end. So you will insert elements from one end and remove elements from the other end. So when you remove the elements, first it will come 1, then 2, then 3, and then 4. So you have to imagine it like a tunnel where the numbers are entering from one end and coming out from the other end. Since 1 came first, so 1 entered from here and then exit from here, then 2 and exit from here, then 3 and then 4. So you'll get 3 and then 4, right? Okay, so this is general basic how a queue works, and that's why we'll call it FIFO, first in first out. So 1 entered first, it is getting out first. 2 entered second, it will get out second, then third, and then fourth. So now this is first in first out. In stack it was last in first out, because we'll remove in the reverse manner. Okay, let's go back to the slides. So a few of the common elements are enqueue and dequeue. You can call them as adding an element or removing an element, right? Just as we saw, we have this queue, You add from this end, you remove from this end. Remove and add. Okay, these are one of the few of the basic operations. Of course, we'll have peek and other methods as well, but adding and removing from a queue are the basic methods. Okay, let's move forward. Now in queues, there are different type of queues. There are simpler queues like the basic FIFO structure, like the one we just saw. Then we have circular queues, we have priority queues, we have double-ended queues. Okay, so let's check this. Okay, for simple queue it is like this. This is front, this is end. Okay, it enters from one side, it gets removed from the other side. This is a simple queue. Similarly, you could have a circular queue. What if the end of this node links back to this one, right? Then it will become a circular queue. It is same as a circular linked list. If you are not sure about the linked list, please go and watch the video on linked list again. Okay, I'll remove from here. Now the other one is priority queue. So difference between priority queue and simple queue is, so in simple queues we entered one first, then 2, then 3, then 4. So when we remove, 1 will come out first, then 2 will come out first, then 3 will come out first, and then 4 will come out first. What if we would have inserted in the form of like this? We would have inserted 3 first, then 4, then 1, then 2. Okay, so when they are inserted, it will form a queue something like this. So we have 3, 4, 1, 2, and when we start removing from this or printing them out, it will print 3, 4, 1, 2. But for a priority queue, you can define a priority. So it can be like, let's say you have defined the priority as the smallest number first. So in whichever order you provide wouldn't matter, and they will get removed in the manner of priority. So output of this for a priority queue would be 1, 2, 3, 4. You can define priorities. For example, when you send jobs to a printer, it print outs the job in priority fashions. Maybe you could have defined that the priority is that the job that would take the smallest amount of time, that should get printed first, and then the next one, and then the next one. So you can define priorities, you can enqueue all the data, and based on the priorities they will get picked and removed. Okay, so don't worry. In this video we are going to cover the theory, and in the next one we are going to go into details for each of the type of queues and plus their implementations as well. Next is double-ended queue. Okay, so double-ended queue is nothing but it says that you can add and remove elements from both ends. So earlier we only had add here, add was here, and remove is from this end, right? But now in double-ended queue, you can remove from this side as well, and you can add from this side as well. So you can have operations like, let's say, rather than having add and remove operations alone, you'll have operations like add front, that will add to the start of the queue. Remove front, that will remove the queue from the front side. Then add last, that will add at the last point, and then remove last. You can name them anything, but the basic principle is that you can add and remove elements from both the ends. Okay, so it could happen that currently you inserted them from left side, so 1, 2, 3, 4 is there, but you can use remove first, so 4 will get removed first. You can use remove last, 1 will get removed last. You can then again remove front, 3 will get removed, and then remove last, 2 will get removed. Or for the last one, actually you can use the remove front as well, but the basic principle is that you can add and remove from both ends. Okay. Let's go next. So queues in Java, they actually, so let's understand the queue interface. So queue is not a class in Java actually. Queue is an interface that extends collection, that extends iterable. We'll cover those things in another video. Now for actually implementing a queue, we have three classes. One is PriorityQueue, it directly implements the queue. The other is linked list. So linked list implements Deque or Deque that extends queue interface. So that's why it provides us the capability that we can do double-ended queue, or we can enqueue and dequeue from both the ends, like we just saw. And similarly, we have ArrayDeque class that again implements the Deque. So now queue has three classes that are implementing the queue interface: PriorityQueue, linked list, and ArrayDeque. Common methods are offer, poll, peek, add, remove, element. Okay, let's jump into them. So first, there are different implementation possibilities. So the first one is linked list. Let's take a look at the linked list. So linked list one is, it forms the simple FIFO queue like we saw in the first example. Plus it's efficient for insertion and deletion, but it has a higher memory usage due to extra node reference, because we know with linked list we have to store the address of the next node n as well, right? Let's take an example of how we will implement a queue using linked list. Okay, so let's implement a queue using linked list. So we'll directly use the queue of type integer. We'll call it queue to new linked list. Okay, what are we missing? Queue, why is it not importing? Once again, QUEUE. It is correct. Why it's not importing? Let me write the import. So import java.util.queue. Okay, so queue is new linked list, so we found a queue of type linked list. Then first we'll enqueue elements. So let's say for a normal queue of linked list type, queue dot, what are the methods we have to add the elements? Add, or we can use offer. So we'll use offer and we'll offer 10. Similarly, queue dot offer 20, queue dot offer 30, right? So we are not implementing a queue from scratch, but we are using few of the implementation, that is one by linked list. Next we will see by PriorityQueue and ArrayDeque. Okay, so we have inserted the elements 10, 20 and 30. Let's print them. System.out.println queue queue. Okay, let's give some space here. Okay, let's run this. So we can see queue 10, 20 and 30 are there, right? Now let's dequeue elements. Okay, so we'll say system.out.println dequeued, dequeued. Okay, and then we'll say queue dot poll. Okay, this is to remove the elements, not just remove the elements, to actually remove the element and fetch the element. Okay, so again we'll do system.out.println and let's see what happens to the queue after the dequeue. Queue after dequeue. Okay, queue, or let's comment this out for now and run. 10. Okay, so you see we had added 10 first and 10 is getting removed first. Now if we check the queue now, 20 and 30. So as we saw, right, for queues, the elements are like going in a tunnel. 10 entered first, 10 is coming out first. It's a normal simple queue. Okay, let's go back. Now last is, let's check another operation, peek at the first element. So we'll say system.out.println peek queue dot peek. Okay, let's run. So for peek we can see 20 because in these two elements this is the front element. Or if we understand from here, let's see it here. Okay, we added 10, then we added 20, then we added 30. Okay, so 10 got added, 10 is in front, 20 got added, and then 30 got added. We removed 10 from the rear end, so 10 got removed, right? Now these two are left. Now we are doing a peek on the front element because this will be the first element out, so we'll get 20, right? If we remove 20, we'll get 30. So insertion order is 10 came first, 10 came out first, 20 was in first, out first, 30 was in first, out first. So 10, 20, 30, 10, 20, 30. Okay, and let's see. So for peek we do not remove the element, so we'll just check this statement again, queue after peek. Okay, so we picked the element 20 but we did not remove it, 20 is still in the list. Okay, this is the implementation of how you can implement a queue using linked list. We added the elements, we removed the elements, we print the elements. Okay, so in this one the main methods were offer, poll and peek. Next one is priority queue. So priority queue actually internally works on heap data structure, so we'll cover that as well when we go into the detail of the priority queue. In this one we need to understand what are the implementations that are available for implementing queue interface. Okay, so similarly for queue, they're ideal when the elements needs to be dequeued based on priority, as we discussed, like for a printer, rather than insertion order. So this one is maintaining the insertion order FIFO, 10 came first, 10 goes out first. It offers log time complexity for enqueuing and dequeuing, of course, because it works on the heap data structure, so it works in logarithmic terms. So let's take an example of how we can implement queue using priority queue. So these are the classes that are already available in Java that we are using to implement the queue. Okay, let's create another, we'll call it queue priority. Okay, let's start public static void main string args. Okay, so we'll create a priority queue. Last time we created a linked list, so if we go here we can see we created a linked list. Now let's create a priority queue. Priority queue is already available in Java. Integer, we'll call it pq priority queue, new priority queue. Okay, now we'll add elements. So again we'll do the same thing, we'll add but it's a priority queue, right? So let's order them, add them in different orders. So let's add 30 first, then pq dot offer, let's add 10, pq dot offer, let's add 20. Okay, now let's print our queue, system dot out dot println priority queue plus pq. Okay, let's run this. Okay, why is it printing 10, 30, 20? Because we added it like that, right? There is 10, there is 30, there is 20. There's no order in this. You don't get much order from this, correct? But the order will come when we want to retrieve the elements. Okay, they are added in manner of heap. So the highest biggest number is in the middle. Okay, let's try to deque an elements and see what happens. So let's deque 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 deque. What's the spelling of deque? One second. deque. Oh, okay. Yeah, deque elements. Okay, so we'll go system.out.println queued dequed, and we'll say pq dot poll. Okay, now once I deque it, let's print it again, system.out.println, or let's remove this for now. Okay, I'm going to deque an element. So remember, this is a priority queue, so you can assign priorities, and by default when we are adding integers, the priority is based on increasing number of order. So please take a minute and guess what will be the output when we deque an element. Okay, so 10 got removed, right? We added in different order, 30, 10, 20, but when we remove, the smallest element came out first, right? If we print the queue again, let's print the queue again. Okay, priority, okay, priority queue after I typed too many EUE, DEQUEUE. Okay, DEQUEU. Oh, okay, EU. What's I every time I'm forgetting the spelling of DQ. Okay, DEQUEUE. Okay, please correct me if the spelling is wrong. Please let me know in the comments. Okay, so we'll print PQ priority. Okay, let's see. So it's 2030. Just to make it more understandable, let's add few more elements. I'll add offer 0, and I'll add pq.offer 40. So we have 5 elements now. Okay, let's run this again. So if you can see, they are saved something like this: 10, 0, 10, 20, 30, 40. Look, they are in sequential order now. Now when we dequeued, it dequeued 0 first, because 0 is the smallest element. Priority queue after first deque became 10, 30, 20, 40. It's restructured. So don't underestimate that it is in the sequential order that it is saved. It is saved on a heap. So when we go to the heap data structure, you'll understand it better. Plus in the next video on priority queue, you'll get it better as well. Now after dequeuing one elements, we can see 10, 30, 20, 40. Then we have printed 10, 30, 40, 20, 40. If I remove one more element, let's take this one only, and let's run. So you can see next time 10 has been removed. And what does the list look like now? Let's run. 20, 30, 40. Okay, so in priority queues, we add the elements, and when we remove the elements, they come out based on priority. Since right now we do not have we have not defined any priority, they are coming out in the sequential order of smallest element first. That is the default priority for integers. Okay, in the next one we'll also see how can we define the priorities. Okay, so last is ArrayDeque. So ArrayDeque is suitable for use cases where both stack and queue implementation functionalities are needed. Plus it provides fast and memory efficient operations at both ends, but does not maintain any specific ordering like a priority queue. Okay, so we can remove and add elements from both ends, but then it depends on us whether we are removing it from the front or the back, right? So let's understand this with the code example. I'll create another class. I'll call it, what's the name? ArrayDeque. Array, or not like this. Let's queue ArrayDeque. Okay. So let's start with public static void main string arguments. Okay. Now let's use the Deque class, the Deque class or the ArrayDeque to implement the queue interface. So as we saw in the previous slide, right? ArrayDeque implements the Deque interface. Deque interface or the Deque interface extends the queue interface. So we are using the ArrayDeque class to implement the queue. And since it has the functionalities or the features from the Deque as well, we can do the insertion and removal from both the ends. So let's implement Deque of type, let's take string Deque. Okay, is equal to new ArrayDeque. Okay, now let's add elements first. Add elements at both ends. Okay, so we'll say Deque dot. Now you can see there are two methods, offer first and offer last. So you can add in the start of the queue or in the end of the queue, like we discussed here, right? That this is our queue. Now we have, for ArrayDeque or double-ended queue, we have the capability to add and remove from front as well as add and remove from back. Okay, let's go. So we'll say Deque dot where do we want to add first? So offer first, so we'll add it in the start, we'll call it first. Similarly, Deque dot offer last, we'll call it last. Okay, let's print system dot out dot println ArrayDeque plus Deque. Okay, let's run. So we can see first is first, last is last. Okay, let me do one more thing. Okay, so before entering first, let's say I added an element Deque dot offer first and I pass 1045 engineering. Okay, so you can see from first end I added 1045 engineering, then I added first as a first, so it will come before 1045 engineering. So we can see first, then 1045 engineering, and then last, because we are adding this one in the last. Okay, okay, let's remove elements from both ends. Okay, so remove elements from both ends. So we'll say system.out.println removed first. Okay, and which method will we use? Deque dot. Now again we have the option to poll first and poll last, so we can remove from first or we can remove from the last as well. So let's remove from first. This way first should get removed, the string first should get removed. So I'll say system.out.println ArrayDeque after poll first. So this content, these classes, this code will be available on the GitHub repo as well. That's why all the points are added well defined. So please go through the Git repository also. Plus Deque. Okay, let's see. So we remove one element. So earlier this is what our ArrayDeque looked like. We removed the first element first and now it has these elements. Okay, let's remove from the other end also. System.out.println, we'll call it remove last plus Deque dot poll, and then we'll use poll last, right? And then let's print it again. println array deque after poll last. So we'll call it deque again. Okay, let's see. Okay, so this was our array deque. We added 1045 engineering first, and then we added first before 1045 engineering, and we added last after in the end, that is last 1045 engineering. So what happened here is, if I'll just quickly explain it one more time. So we had a queue, we added 1045 engineering, or let's remove, we added 1045 engineering. Okay, I'll call it 1045. Then since we can add from front also and last also, we add first. So we added in the front, we called it first. Then we added in the last, we called it last. So you can see we added from the front side also, we added from the last side also. Then we remove from the front, and then we remove from the last. Okay, let's go back. So we removed from the front, so first got removed, we had 1045 engineering and last. Then we did deque.poll last, so we removed from the last was removed, and now the elements left is only 1045 engineering. Okay, I hope this is clear. And all these methods, whether it is offer first, offer last, poll first, poll last, allow Deque to perform operations from both ends. So important methods for a Deque now was, or for a ArrayDeque was, poll first, poll last, offer first, offer last, right? Okay, let's move forward. Now this is I'll not go through this one, because in the next video we'll be going through each implementation one by one and understand how they work in detail. This video is more from the theoretical perspective, but please take a screenshot or take a look at this, pause the video, understand the differences between the implementation via LinkedList, PriorityQueue and ArrayDeque. They have different implementations, they provide different features. If you go through some from performance perspective, LinkedList takes O of 1 for NQ and DQ, PriorityQueue takes log n for insertion and removal, and ArrayDeque again O of 1 for adding, removing elements at both sides, because you can add and remove elements from both the sides, right? For this one, NQ and DQ, you can add elements from one side, remove elements from other side, always O of 1. This, since it implements binary heap or binary heap data structure, that's why log of n for insertion and removal. Please note these differences and go through them. Okay, so finally, for the summary, queues are fundamental data structures that supports FIFO operation. As a simple queue, when you understand, it supports FIFO operation. Though we did discuss double-ended queue, or where we could add elements from the front as well as last, and we could remove as well. But in general, queues follows FIFO operations: first in, first out. Stack follows LIFO, last in, first out. Java provides various implementation, each for different use cases, as we just discussed, and key operations always include NQ, DQ and peek, adding an element, removing an element, and seeing the element, right? I hope it helps. If there are still any questions or anything, please let me know in the comments. In the next video, we'll be covering the code examples for all the three. Okay, that's all from today's video, everyone. For anything, please let me know. In the end, please like, share and subscribe.